Dr. Gokalp, in terms of technical expertise, what inputs does CNRS bring to the Scope Big project?
The global idea of the project is to, once again, to hybridize or to integrate solar thermal, let's say, electricity generation or steam generation with chemical, either from biomass or from fossil fuels, but mostly biomass, we hope. And this could be done either by combusting the biomass or the fossil fuels, or by gasifying them. And then with the gasification, we shall obtain some combustible gases that we call syngas. And then we shall get also steam or heat in general by combusting this syngas. Then the whole thing is to combine or to optimize the solar part of the project with the gasification part, depending on the available biomass, the needed power range, etc.
Okay. Now, between combustion and gasification as technologies, which do you think has better scope for larger penetration in the industry, especially when you join it with solar thermal technologies?
Well, this is a good question, in fact, because we discussed and we are still discussing this also with Thermax and other colleagues in India. Probably both approaches have their advantages. Generally speaking, we may think that combustion is a more direct application. I mean by that you just burn let's say the fuel, the feedstock, and then you got the heat, and then you transform it into steam and electricity, etc. Whereas for gasification, well, you need the gasification step first, and then you obtain some combustible gas, and then you use again this gas for heat production or steam production, etc. Then we may think that in the gasification there is an additional step. But if we take into account other considerations like the pollution emission issues, we know that gasification is a process occurring at lower temperatures compared to combustion, so that some emissions like the sulfur oxides or nitric oxides are produced less compared to combustion. And also, even concerning the CO2, we may think that with gasification there is at least one innovative way of capturing the CO2. So when you combine the facility of the application, but on the other hand the advantages of gasification towards the emission issues, we need probably the end user should decide which way to go, and both techniques will certainly work. And also it may depend how, in fact, the whole project is will be integrated to a global project. If already a gasification system exists, or if gasification is needed to produce some syngas to go to liquid fuels by further transformations, then the end user may decide to go to gasification in an integrated way. But if the project needs only steam and then electricity or steam, then the end user may decide to stay on combustion. So several combinations are possible. Once again, I think the end user should discuss with the technology providers to decide which way to go by taking into account all these arguments and factors that I just mentioned.
Okay. Um, Thank you. Now, at what scales, in terms of capacity, can gasification compete with other conventional power generation technologies?
Um, well, globally, gasification is more expensive than combustion, at least today, because once again there is this, the gasification step, which is an additional step. But as I said, especially concerning the CO2 capture issue, which is and will become mandatory for every, but especially for large power plants. If you include the cost of CO2 capture from combustion systems, and then in that case, as I said just before, gasification offers a CO2 separation easier than with combustion systems, then in that case, both costs from combustion systems and gasification systems, at least for coal, when we use coal as fuel, the cost of both systems become comparable, and in the long run, it may be that the gasification may become advantageous. So I think we can give this answer right now. Then once again, if you take the emission issues, CO2, plus also the fact that the sulfur oxide and nitric oxide emissions are lower with the gasification, indeed gasification in the long run may become interesting. Besides, as you know, gasification is a both multi-fuel and also multi-product process, which means that you can use several resources to gasify. You can even combine, co-gasify several things. And then the gasification, once you got the, by gasification, once you got the syngas, well, you can use it as a fuel, but also you can use it as a chemical to produce some interesting other chemicals, liquid fuels, etc. Then the whole thing, the good decision will come certainly when the end user will consider all these aspects.
That. Now,
Okay.
in the context of off-grid power generation, what, in your opinion, is the future of cogeneration technologies like solar and biomass or geothermal and biomass?
Well, for sure, these are good opportunities for all countries, in fact, not only very large population countries and developing countries like India, but also for others. As you know, the objective is to, in the coming decades, to reduce the world dependency on fossil fuels, which means then decreasing also in parallel the CO2 emissions. So combining or hybridizing or co-generating electricity, power and electricity from renewables like solar or like wind or geothermal energy, and combined then with fossil fuels is a good idea. Of course, it has a let's say different meaning if it is for off-grid applications for remote places, small villages, islands, etc. Then it becomes really interesting, of course, because it brings a kind of independency to the local community. Probably under such conditions, we should first start with the full renewable, let's say, full wind or full 100% solar or geothermal, etc. And in cases where the storage of energy, because these are, as you know, intermittent resources, especially solar and wind, if the heat storage or the energy storage is not working, and then we need to go indeed to hybridization with some other solid or gaseous fuels. But of course, in that case also the best idea is to hybridize with biomass, because as you know, we say that biomass is CO2 neutral. The CO2 that we are emitting by combusting or gasifying biomass is recovered later on by biomass to grow. Then combining solar, for example, with biomass is indeed an excellent idea, because it's a kind of CO2 neutral, and even we may say it's a CO2 sink, and we are taking some CO2 from the atmosphere. Then these techniques are certainly, or processes, technologies are very appropriate for off-grid applications too, both for these emission purposes, but also to give some independency, energy independency of these local communities by using their resources. Solar is a natural resource, and if they have also biomass. When we say, of course, biomass, we mean in general organic material. So it can be biomass from forest residues or agricultural residues, but it could be also, any organic waste from village uses, or even if it is a bigger city, if it has, for example, this city water purification systems, then there is this material we call sewage sludge that can be also gasify, as it is an organic material also. So you can also think about this kind of organic resources as biomass to be combined with the solar, for example, or why not with the wind. And then in those cases, you both use your local resources to produce energy, but also you give some energetic use or valorization to some very difficult to handle waste, like this water purification sludge or sewage sludge that we don't have any other good solution today. So technologies are more and more permitting this kind of innovative combinations between energy valorization of waste material and local use and energy independency, etc. So we should definitely work on these topics more and more altogether.
Yes. Thank you so much, sir.
Okay, thank you.